Hey everybody, in this video I'm going to go through inscribed angles and intercepted arcs. Now, to start off, I drew a circle with center A, and we are going to begin by drawing an inscribed angle. So our inscribed angle is going to be formed by two chords. So our first chord is chord BC, and our second chord is chord CD. So this is our inscribed angle here. And it really is the angle that has the vertex on the circle. So it has vertex on the circle, and then again formed by those two chords. So inscribed angles form what is called intercepted arcs within the circle. So I just highlighted what is the intercepted arc. So this is intercepted because if the angle kept going, that would be the part of the circle that the angle intercepts. So the intercepted arc is opposite of an inscribed angle. Oops, opposite of an inscribed angle. And we can actually talk about the measure of the intercepted arc in relation to the inscribed angle. So this is the inscribed angle theorem. Inscribed angle theorem. And essentially, the inscribed angle theorem states that an inscribed angle, or an angle inscribed within a circle, so I'm just going to say in a circle in parentheses, measures half of the intercepted arc, measures 1/2 of the intercepted arc. So, in other words, I know this inscribed angle is half, or I'm just going to actually write it like this, half of the intercepted arc. Or the intercepted arc is double the inscribed angle. So in this diagram, this inscribed angle, the measure of angle BCD is half of the measure of arc BD. And the measure of arc BD is double that angle, double the measure of angle BCD. All right, so what else can we do with this? Well, actually, if I know that another arc has this measure, if I have two inscribed angles that have the same intercepted arc, so if I have the second angle B, E, D, this has to have the same measure as the other inscribed angle. So this is what we call the arc-intercept corollary. Arc-intercept corollary, meaning it follows from this theorem. It's kind of like a sub-theorem. If two inscribed angles intercept the same arc, then they are equal measure. I apologize for my handwriting here. All right. So again, if I have that same intercepted arc for both inscribed angles, I have angle BED and angle BCD. They both have intercepted arc BD, so I know then that the measure of angle BCD is equal to the measure of angle BED. And both of those are half of the intercepted arc. So let's say, for example, this intercepted arc is 80 degrees. So that's the measure of arc BD. Then both of these angles are 40, right? This has to be 40 degrees, half of that. And this also has to be 40 degrees. They both are half of the intercepted arc. All right. So this was one corollary. Let's talk about a couple other corollaries to this inscribed angle theorem. So I'm actually going to put a box around this corollary. Ooh, funky, funky, funky. Not really what I wanted. That's okay. I'll just leave it underlined. So I'm going to draw another circle, actually. Ooh, yeah, no, let's try again. Ooh, I wonder if I can just copy this one. Ah, love it. So this is going to be circle A again. I'm going to do this one a little bit smaller. And it's circle A because it has a center at A. And first I want to talk about the right angle corollary. So let's write that out. Right angle corollary. And the right angle corollary really just states that an angle inscribed in a semicircle is a right angle. So what does that mean? Well, a semicircle is half of a circle, and that is really formed by any diameter. So let's draw a diameter here. This can be B, and this can be C. So this is diameter BC. So now I have essentially two semicircles or two arcs that are 180 degrees. And let's see, I'm going to draw another point here. This will be D. So if I talk about arc BDC, because it is a semicircle, it's 180 degrees. So if I have an angle inscribed in this semicircle, essentially I have this angle maybe BDC. Oh, I don't have a little dot here. That's no good. BDC has to be a right angle. So essentially, I have the measure of angle BDC is 90 because it is inscribed in that semicircle. So the intercepted arc here, if I draw the intercepted arc, this is 180 degrees. All right. And then the converse of this, if an inscribed angle is a right angle, then its intercepted arc is a semicircle. I knew it wouldn't fit. Its intercepted arc is a semicircle, meaning it measures 180 degrees. Intercepted is a semicircle. And I want to note, we could talk about the arc intercept corollary again here. I could draw lots of different right angles within a semicircle. So let's see, I'm gonna draw another one. Here, this will be point E. So BEC is a right angle as well. And I could say that the measure of angle BDC is equal to the measure of angle BEC because of that arc intercept corollary. If you have two inscribed angles that intercept the same arc, they are the same. Please let me know what questions you have and move forward to the next portion of our course.